Matrix multiplication. What we are going to learn is something very important and quite fundamental to matrices. It's one of the fundamental concepts of matrices that will be applied throughout the journey of matrices. It's called matrix multiplication. Now, let me get into this. This is a bit of a lengthier topic for me to explain, so hear me out with patience, right? And once I've explained all of that thoroughly, I can take questions in the end, right? And we might do a few questions to sort of get more clarity on it. Now, matrix multiplication is not scalar multiplication. Remember that. When I say scalar multiplication, if I have a matrix A, 1, 2, 3, 4, and I say 2A, that means I'm multiplying the whole matrix by 2. This is 2, 4, 6, 8. This kind of a multiplication is called scalar multiplication, when I am multiplying a number with the matrix itself. But when I am talking about matrix multiplication, what I am going to do is I am going to multiply two matrices in, themselves. We're going to multiply two matrices. Now, before we multiply two matrices, let's understand the basic fundamental or the rule or a prerequisite, should I say, or a condition. Prerequisite or a condition that the two matrices have to meet in order to multiply together. The precondition for them to multiply is that columns of the left matrix should be equal to the rows of the right matrix. Now let's understand what is left and right. Let us say I have two matrices A, and let's say matrix 1 is 1, 2, 3. So the order of this matrix is it's got one row and three columns, 1 cross 3. And let's say I have another matrix B, which is a 3 cross 3 matrix, or maybe a 3 cross 2 matrix. So 3 cross 2 matrix means 3 rows, and I say 1, 2, 3, and only 2 columns. Let's say 0, 1, 2. Now the order of matrix B is 3 cross 2, 3 rows and only 2 columns. Now, I can only multiply A and B, A multiplied by B, if this particular condition is met. The matrix that is written first is called, I call it as the left matrix. And the matrix that is written after the product, I call it as the right matrix. Now let's understand the rule or the prerequisite or the condition. Columns of the left matrix. What is the order of A cross B? What is the order of matrix A? It is 1 cross 3. 1 cross 3. And what is the order of matrix B? 3 cross 2. So this is matrix A, this is matrix B, and I'm trying to find their product. The condition says that the column of left matrix, how many columns do I have in the left matrix? 3 columns. Should be equal to the rows of the right matrix. So here 3 is equal to 3. So that means that yes, I can find the product of A and B. But when we deal with regular mathematics, the arithmetic, if I say 3 multiplied by 2 is 6, and obviously 2 multiplied by 3 is also 6. So when we do our regular arithmetic mathematics, and when we do multiplication, order does not matter. 3 times 2 is also 6, and 2 times 3 is also 6. But in the world of matrices, order is very, very important, which essentially means that A cross B is not equal to B cross A. And we will understand this later down the track, once we have understood the matrix product itself. Now, coming back to A cross B, the product, can I, if I change the color of my pen, can I multiply B with A? As I said, order is important. So that means these two might be different. Let's see if they really are. So my condition says the columns of the left matrix, now B becomes my left matrix and A becomes my right matrix. What is the order of B? B is 3 cross 1. So 3 cross 2, my bad. Is 3 cross 2. Whereas the order of A was 1 cross 3. Now, according to my condition, the column of left matrix must be equal to the rows of the right matrix in order for the product to exist. Let's look at it. The columns of the left matrix is 2 and the rows are 1, which means they are not equal, which simply means that B cross A does not exist. Even when you had the existence of A cross B already. And that is why the order of matrices, especially in the product, is very, very important. If this condition is not met, this equality condition is not met, the product will not exist. If you'll try to do it on CAS, it'll say false, or it'll say it doesn't exist or undefined or something. Now let's try to understand, having said that, let's try to actually multiply two matrices. And I'll take another example, maybe an easier one for you to digest, because matrix multiplication is slightly challenging to digest, right? Let us say I have a matrix A as 1, 2, 3, and 4. And I've got another matrix B as 0, 1, 0, 2. I've just made something up. Now I am asked to find A cross B. But before I actually deep dive into the matrix itself, the product itself, I need to check whether the condition satisfies for this product to exist or not. A is the left matrix. The order of A is 2 cross 2. and the order of B is 2 cross 2. So columns of the left matrix is equal to the rows of the right matrix. Now, one important point before I actually go and do the product of this matrix is once you have multiplied the two matrices, you will still get a matrix, right? Let's say you get a matrix C, another matrix. What will be the order of that matrix? The order of that matrix is the rows of left matrix times the columns of the right matrix. So if I multiply A cross B here, I will get a matrix which is a 2 cross 2. And if I go back to the example that I gave you here, where this example here, A cross B exists, yes, because the columns of the left is equal to the rows of the right. But what is the order of this resultant matrix? It will be 1 cross 2. 1 row and 2 columns. So with that in mind, let us quickly go and try to multiply these two matrices A and B. Very, very important. Be with me. If you're lost, give me a shout. Right. All right, I'll write matrix A on the left because I'm asked to find A cross B, so I have to ensure that matrix A is written on the left. 1, 2, 3, 4. And matrix B on the right, which is 0, 1, 0, 2. Now, this is where it becomes slightly challenging, but if you'll stay with me, you'll be fine. I pick up, and I'll maybe change the color. I pick up the first row of the left matrix. I repeat, I pick up the first row of the left matrix and first column of the right matrix. And now I create a bigger matrix because I have to do some mathematics with it. The first element of this row, the first row, needs to be multiplied with the first element of the first column. 1 times 0. After this, I will always say a plus. The second element of the first row will now multiply the second element of the first column of the right matrix, which means 2 times 0. That forms the first element of the resultant matrix. Now, once I've done that, I will now move to the next column. I will move to the next column of the right matrix. And I'll do exactly the same. I will not move the row of the left matrix, mind you. And I'll do the same thing. 1 times 1. I have moved the column, so I move the column here as well. So 1 times 1 plus 2 times 2. Now, I have now reached the end of the columns of my right matrix. What I now do is I switch the row on the left matrix and I come here. And this was 1 and 2. And I come back to the first column of the right matrix. And I exactly do the same thing. 3 times 0. And I now, since I moved the row, I move the row here as well. So I'll say 3 times 0. Always a plus and a 4 times 0. And then I simply move the row, sorry, the column again. And I do the same thing. 3 times 1 plus 4 times 2. And I now have reached the end of the column of my right matrix. And I have also reached the end of the row as well. And eventually my matrix multiplication is done. I told you at the start, this is going to be a 2 cross 2 matrix. And that's what we've got. I will just solve this now to get to the final point. 1 times 0 is 0, plus 2 times 0 is 0. 1 times 1 is 1, plus 2 times 2 is 4. 3 times 0 is 0, plus 4 times 0 is 0. And 3 times 1 is 3, plus 4 times 2 is 8. So finally, my A cross B, the product is 0, 5, 0, 11. That is, in its very, very simplistic terms, how you multiply two matrices, ensuring that the precondition is met, and eventually how you navigate through the two matrices as well. Now, you can ask me a question that this is a CAS active exam. Why do I need to know this? I agree. At times in multiple choice in questions, you might be asked this logic that can I multiply this and this? Can I multiply this and this? So you need to know that logic to score that 1 mark of that multiple choice where CAS cannot help. CAS can certainly give you A cross B, but CAS cannot tell you how on earth you reach to this result. So, and 1 mark at times could be 1 study score. So make sure that you've understood this fundamental. I'll make you do a few after this so that you grasp it properly. All good? Cool. Thank you.